Alright, I'll be doing the odds off of Chapter 5 Expressions, the study guide for your upcoming test. The first one says, use the distributive property to write 5 times the quantity negative 3 plus 7 as an equivalent expression. What is the value of the expression? Alright, well, it wants us to write it as an equivalent expression, so it's not just wanting us to solve to start. It does want the value at the end, but it wants us to use the distributive property. Remember, that's taking this number times every term in the group. So we have 5 times negative 3, so I could write it like this: 5 times negative 3 plus 5 times 7. Noticing that both terms are getting multiplied by 5. Could also write it like this: negative 15 when I distribute to the first one, 35 when I distribute to the second one. And then, of course, when I add two things that have different signs, I subtract their absolute values and use the sign of the larger, which is positive. If I were to do it right over here now with order of operation, since I could do this, I would say different sign subtract, sign of the larger, which would have been 4, and 4 times 5 is 20. Alright, the next one wants us to subtract, and so one thing I would tell you with subtract is to be careful, because people a lot of times subtract the first thing, but they forget to get this minus distributed back to this back term. So remember, you have one of those things. You could do leave, change, opposite. I suggest you bust things out of jail with the distributive property, so that would be a negative 6g plus a negative 7. So I have the opposite of g plus negative 9. I'm going to do my leave, change, opposite here, plus this negative 6g plus negative 7. So, like terms, they have the same sign, so I add and use that same sign. Remember, there is one of these, so when I add them together, I should say negative 1, I will add them together and get negative 7g. These are like terms as well. They're constants. So negative 9 plus negative 7, they have the same sign, so I add and use that same sign, plus negative 16. Of course, you could see it written as negative 7g minus 16. We need to recognize these two things as the exact same equivalent expressions. All right, number 5 says, what is the value of this? Well, that's just a straight order of operation problem. Could you do the distributive property? Yes, but you don't really need it. So I'm going to do leave, change, opposite to get rid of all my subtraction. That will allow me to use the commutative property to get like terms together. So I can do this inside of here. They have different signs, so I subtract. Sign of the larger is negative. I'm, by the way, going through this order of operations, which is grouping symbols first. I'm looking for exponents. I don't have any. I do have a multiplication problem right here. 3 times negative 4. They have different signs, so your answer is always negative. Or you have 1 negative, which is odd, negative. So now I'm down to 8 plus the answer to this thing plus this, negative 14. So now I'm ready to add and subtract left to right. They have different signs, so I subtract sign of the larger. So I would have negative 4. And then negative 4 plus negative 14, they have the same sign, so I add and use that same sign, negative 18. Next one says, what is the value of negative 3a minus 4b if a equals 6? Remember, this is really all you're doing, substituting, but make sure you put it in parentheses. That way it doesn't look like a negative 36. And when b equals 5, put it in parentheses. I would do leave, change, opposite. Different signs, always negative in multiplication, or 1 negative, you can count it that way. 1 is odd. 1 is odd again. Now I'm adding and they have the same sign, so I add and use that same sign, negative 38. Number 9 wants the next 3 terms in this sequence, so I have to figure out what the pattern is. So I might do that with subtraction. If I subtract, I get 0.9. If I subtract, I get 0.9. If I subtract, I get 0.9. So guess what? It's going up 0.9 each time. So if I want the next 3, I just need to keep adding 0.9, which would get me to 9.8, and then it would get me to 10.7, and it would get me to 11.6. You might remember we also worked on finding an expression that would actually relate this to where it is in the sequence. So I'm going to do that as well. Since it's going up 0.9 each time, remember that is the constant rate of change. So y equals 0.9x. And then if you follow this pattern down here, you'd get down to 0, or where x is 0, that's where you're hitting the y-axis. So you remember, this is the slope. This is going to be your y-intercept on this slope-intercept form. So if I subtract 9 right here, I'm going to get 5.3. There's your y-intercept. And so we have y equals 0.9x plus 5.3. That could get me to any term at any point that I wanted to. So if I did, like, we'll just check it right here with 3 and 8. If I took 3 times 0.9, I would get 2.7. 2.7 plus 5.3 is 8. So if I wanted the thousandth term, I could skip all this adding repetitively to get to the thousandth term. I would just take 1,000 times 0.9, which would be 900, add 5.3, and I would be at 905.3. All right, number 11. It's asking for which property is being shown on each one of these. So when I look at this, 7, 4G, 7, 4G, the order did not change, so it's not commutative. So I'm looking at the grouping symbol. 7 and 4 were friends. Now 4 and G are friends. The grouping change, that is called the associative property of addition. B, when I look at B, well, it looks like maybe the same thing because the groupings look like they changed, but did they? 8, 5, 4, 5, 4, 8, 5 and 4 were friends, 5 and 4 are still friends, so that's not the associative property, that's simply the commutative property of multiplication because the 8 was multiplied on the front, now it's multiplied on the back. All that happened was the order changed, which is okay in addition and multiplication. And C, looks like they broke them out of jail with the distributive property. 3 times 2p equals 6p. 3 times 5 equals 15 with the plus sign back in between them. The last one says factor the area of the rectangle to find the possible dimensions of the rectangle. Factor means let's break this down by anything that we have in common. I notice something in common with 12m and 20. I think 4 will go into both those. So if I factored out a 4, it's kind of like, remember, dividing it and putting it back in jail. So I'm taking out the 4. So let me divide out a 4. 12m divided by 4 would be 3m. 20 divided by 4 would be 5. And so 4 times 3m plus 5 could have been the dimensions of this rectangle. It's called factoring